Hello there and welcome to the series of videos going through the content of A-Level Maths. Here we're looking at solving trigonometric equations so we can answer questions from exercise 7D. So we're going to be solving a lot of different types of trigonometric equations. I'll show you multiple different strategies that you may be able to use with inside a question, and then we'll have a go at some of our own afterwards. And there are lots of questions in exercise 7D, so make sure you do get a lot of practice at this at the end. So the first equation we're going to solve is 4 cos theta minus 30 equals 8 root 2 sine 30, all answers in the given range from 0 to 360 to 1 decimal place. So where are we going to start with this? I think the left hand side here is probably a little bit more trickier, so we'll probably expand this, and we'll expand this using the angle rule for cos. So we'll expand theta minus 30. So in this case here, it's going to be 4 cos theta cos 30 plus 4 sine theta sine 30 equals 8 root 2 sine theta. Now we can simplify this cos 30 and the cos and the sine 30. So let's go ahead and do that using the exact values where possible. And simplify timesing through by, we don't need to times through by 2 because we've got numbers that cancel out. So great, this is what we've got at the moment. It's still got sines and coses in it though, and can we make a tan out of this? Well, yeah, I think if we move the sines onto one side, factorise a little bit, we can make a sine over cos equals tan. So in this case here, divide through by 2, subtract the sine onto the other side, factorise out the sine, and now we've effectively got something times cos equals something times sine. So if we divide by cos, divide by the sine something, and then we're going to get a tan. So divide by 4 root 2 minus 1 and divide by cos. We're going to get sine over cos equals root 3 over 4 root 2 minus 1. So this must be the same as tan. Great, so we remember that sine over cos gives us tan. So now what are we going to do with this tan function? We're going to do inverse tan of it to get 20.4, and then remember the way that we work out the extra angles on tan is to just subtract or add 180 degrees either way. So in this case here we're going to get 200.4. Okay, there we are. So that's the answer to this question here then. So what we did there was we expanded the cos theta minus 30 and then rearranged it into sine over cos equals tan. Okay, another different question here with a different strategy. Okay, so we have a different question here now. It's going to be a different strategy that we're going to use this time. The question is 3 cos 2x minus cos x plus 2 equals 0. All answers in the given range from 0 to 360. Give your answers to 1 decimal place where appropriate. So, where are we going to start with 3 cos 2x minus cos x plus 2 equals 0? Well, it kind of resembles a quadratic one, but the 2 is just in the wrong place. The 2 should be as a power rather than a multiple of x. But there is a rule that we can use to turn cos 2x into a power of cos. And if you remember the cos 2x, one of the double angle identities, is that cos 2x is equal to 2 cos squared x minus 1. And now what this is going to do is it's going to create a quadratic in x, in cos x, that we can then go ahead and solve. If this cos x was actually a sine x, we could still do this question here, but we would use the other cos 2x identity, 1 minus 2 sine squared x, rather than the cos one, to make a quadratic in cos x. So expand your brackets, simplify the numbers together, and then factorise the cos quadratic. In this case here, we're going to get cos x equals minus a third and cos x equals a half, and we can solve both of these. So the first thing we're going to need to do is x is equal to 109.5 for the first one, and 360 minus it will give us 250.5. And then cos x equals a half, well, we know that that's going to be 60 degrees and 300 degrees, so these are our 4 combined answers. So in this case here, we replaced cos 2x with a single angle x, but we're going to use the identity of 2 cos squared x minus 1. Okay, you wouldn't have a chance of solving this equation if you've got this if you've got different multiples of x, that's why we've got the double angle formulas to help us get it back down into a single multiple of x inside the angle. Okay, next question then, solve 2 tan 2y equals, 2 tan 2y tan y equals 3, that was a bit of a mouthful, from 0 to 2 pi, answers to 2 decimal places. So again, we've got a trig function with a different multiple of the angle, so we're going to need to use a double angle formula rule on the 2 tan 2y. So in this case here, replacing the tan 2y with 2 tan y over 1 minus tan squared y, and rearranging this a little bit. So we're going to now multiply the brackets by 2 to get a 4 on the top. Let's now multiply the two expressions on the left hand side together. Remember, if we're timesing an expression by just something that's linear, treat it as a fraction over 1 and times top together and bottoms together. So 4 tan y times another tan y will give us 4 tan squared y, and on the bottom stays as it is before. Let's now get the 1 minus tan squared y up onto the top row, so times both sides by that. And now we can group together the tan squareds and square root at some point. So add 3 tan squared onto the other side, divide through by 7, and then square root, but being very careful when we square root to take the positive and negative answers. So tan y is equal to plus or minus the square root of 3 over 7. And now we've got two equations for the price of one here. We've got the negative equation and the positive equation. The positive equation will give us roots of 0.58 when in radians mode. The key to this question, knowing that it was in radians mode, was that your range of y values was between 0 and 2 pi. And then we'll just add pi on because that's adding on 180 degrees effectively. So 3.72 is your second answer for this first equation. Let's now go for the negative root 3 over 7. In this case here, do tan inverse and you get 2.56. Add on pi onto that and you get 5.70. And all of these are to 2 decimal places, so these are our final answers. Okay, so basically whenever you have a different multiple of your trig angle, you've got to use a double angle rule to help get rid of that. You can only really solve trig equations if you've got the same multiple on the angle. Okay, a classic question that I've seen multiple times in exams before. Part A is going to expand sine 2a plus a to show that sine 3a is equal to 3 sine a minus 4 sine cubed a. Well, let's go ahead and do that then. Let's use the sine angle rule. So sine a plus b is equal to sine a cos b plus cos a sine b. And what we'll do is we'll set b equal to 2a. So replacing the values inside the angle with the 2a and their a value, and we're going to get sine 2a cos a plus cos 2a sine a, and now we're going to expand both of these sine 2a and cos 2a expressions using their double angle rules. So in this case here it's going to be 2 sine a cos a times cos a plus, and what we're looking for is our answer in terms of sine. So in this case here, we're going to use 1 minus 2 sine squared a times sine a as the identity for cos 2a. Now expand your brackets and do a bit of simplifying. So it's going to be 2 sine a cos squared a plus sine a minus 2 sine cubed a. Now we want our answer only with sines in it, so we're going to have to get rid of this cos squared a to a 1 minus sine squared. So in this case here it's going to be 2 sine a brackets 1 minus sine squared a, and then it's going to be plus sine a minus 2 sine cubed a. Expand the brackets and simplify, and we get what we're looking for here. We're going to get 3 sine a minus 4 sine cubed a. Okay, so a very standard question, this to work out sine 3a. You can do very similar things with cos 3a as well. It's just taken the double angle formula as an extra step further. And then you always get a part B, and it's something to do with this matching up with this equation here. So hence solve it otherwise. 16 sine cubed theta minus 12 sine theta minus 2 root 3 equals 0. Now notice here how this expression here is almost identical to this one here. Number one, the signs are different, so we're going to have to sort that out. And it looks like it's scale factored up by a multiple of 4 as well. Okay, so let's see how we can link the two parts together in this equation here. So if we were to replace the a's with thetas, yeah, that's fairly standard. Multiply all three by 4. We're nearly there. 12 sine theta minus 16 sine cubed theta. And multiply by minus 1. Now we've got exactly what we need on the left hand side of our expression here. It's equivalent to minus 4 sine 3 theta. So what we can do in our equation is just replace, we can subtract 2 root 3 as well. So what we've effectively got here is the equation that we want to solve on the right hand side, and we've shown that it's equivalent to this equation on the left hand side. So as long as we can solve the equation on the left hand side, we've solved the equation on the right hand side. So in this case here, this is our equation to solve. Minus 4 sine 3 theta minus 2 root 3 is equal to 0. So let's now go ahead and solve this equation. Multiply through by minus 1, subtract the 2 root 3 onto the other side, divide through by 4, and we're going to get sine 3 theta equals minus root 3 over 2. Now remember here we've got sine at 3 theta, so we're going to have to expand the range of theta angles. So 3 theta is now going to be in between 0 to 6 pi. That's really important to get all of our solutions. And now we're going to compute the inverse sine, so it's minus pi over 3. And now we're going to work out all the other solutions for the sine graph. So in this case here, the sine graph is going to go through a loop once, through a loop twice, through a loop 3 times. And all of these solutions at minus root 3 over 2 are going to be on the bottom here. Minus root 3 over 2. First one being minus pi by 3, so that would be the solution down this side. So in this case here we'll do pi add this angle here, the magnitude of this angle here, so 4 pi by 3. We're going to get the next one at 5 pi by 3. We're going to get the next one at 10 pi by 3, we'll miss a space there, so 10 pi by 3, 11 pi by 3, 16 pi by 3 all the way up here, and 17 pi by 3 to finish this off. Okay, so lots of angles there, and generally we do get lots of angles when we've got something like a sine 3 theta, like we have here. But we're not finished there, we need to find the values for theta, so we've got to now divide all of our solutions by 3. So in this case here it's going to be theta is 4 over 9 pi, 5 over 9 pi, 10 over 9 pi, 11 over 9 pi, 16 over 9 pi, and 17 over 9 pi. Very, very standard question, this one. Make sure you know how to create the formula for sine 3a or sine 3 theta, and then think about how you're going to link it into the next question. What scale factor multiples do we have to show that the right hand side is equal to the left hand side, etc., etc. So we've got an easier equation to solve rather than a difficult cubic equation to solve like we have here. And all of the solutions to this equation here will be solutions to this original equation here. You can try one or two of them into the theta values to just make sure they do work. Right, I've got 3 questions here for you, 2 on this page, and then we'll have a go at 1 afterwards on the next page. So pause the video and try these 2 questions out. Right then, let's have a go at the first question here then. So we've got 3 cos theta equals 2 sine theta plus 60. The first thing I'd probably think of doing here is expanding this right hand side. So hopefully that was your first step as well. If it wasn't your first step, then pause the video and just have a go at this again, expanding this right hand side here. When you do expand the right hand side, you get sine theta cos 60 plus cos theta sine 60. So in this case here, when we now expand the brackets and multiply through by 2, we're going to get 2, and then cos 60 is a half, so that will just cancel each other out. And then sine 60 is root 3 over 2, so this is just now going to be root 3 times cos 60. Cos theta, I mean. Okay, now it looks like we're probably going to head towards a sine over cos equals tan, so if we subtract square root 3 cos theta from both sides and do a bit of factorising all in one step, we're going to get 3 minus root 3 cos theta equals sine theta. Divide through by cos, and we're going to get 3 minus root 3 equals tan theta. So what have I done here? I've divided both sides by cos, and I get tan theta equals 3 minus root 3. And now all I've got to do is do inverse tan of 3 minus root 3. And this here is inverse tan 3 minus root 3. And I get 51.7. And add on 180 degrees onto that to get my second solution, 231.7. So there we are, those are our two answers for this question here. So hopefully that went okay for you as well. Let's have a go at the second one here. Sine 2 theta equals sine theta. Well, I can never solve an equation where we've got different multiples of the angles, so I'll have to expand the left-hand side. The left-hand side expands to sine 2 sine theta cos theta equals sine theta. Now maybe you'd be tempted here just to cancel out sines from both sides. Please never do that. The only way you can do that, so the reason you can't do that is because sine theta may equal 0. And indeed, if you were to subtract sine theta onto the other side and then factorise it out, you're going to get 2 cos theta minus 1 multiplied by sine theta. So in this case here, sine theta could equal 0, because we've got two things that are multiplying to make 0, so one of these things must be 0. So theta is therefore 0, 180, or 360. Let's have a look at the second equation now. Cos theta equals a half. Well, I know this can happen at 60 degrees or 300 degrees. Oh, but it's in radians, so I'll have to convert all of my answers. That's a shame. 0, pi, 2 pi, 60 degrees is pi by 3, and 300 degrees is 5 pi by 3. Yeah, don't forget to check whether your answers are going to be left in degrees or radians moded. I forgot to look, so I had to convert right at the end. Okay, let's have a look at the second question, or third question really, that's on offer to you. Have a go at this question here, pause the video and try this one out. Okay then, let's have a go at this one here now. Now we've got a cos 2 theta and a 1 minus cos theta, and I can't have different multiples of my angles when I'm solving an equation. So I'm going to need to expand the cos 2 theta here. I'm going to use the 2 cos squared theta minus 1 version of the cos 2 theta identity, because therefore I can then get a quadratic in terms of cos, and then hopefully this will head towards solving the equation for me. So if I now move everything onto one side, you can clearly see that I'm forming a quadratic in terms of cos here. Now I need to expand the brackets or factorise. In this case I'm going to get 2 cos theta, and in this case here, In this case here, I don't get anything nice. Nothing nicely factorizes into this. So what I'm going to have to do then is I'm going to have to use the quadratic formula, or use the polynomial solver on my calculator. The first cos theta value is going to be -1 plus root 17 over 4, and -1 minus root 17 over 4. Let's find the first cos solutions to the first answer then. So we're going to do cos -1 of that value. We're going to get 38.7. And looking at where the other angle is going to lie, it's going to be at -38.7. Let's now have a look at the second solution that we get here and change it for a negative. And in this case here, it's this value here is -1.28, so we get no solutions here. So the only answers that we get here are 38.7 and -38.7. So this exercise is a really tricky one. You do need to invest a lot of time in solving trigonometric equations, so please make sure you do. Please make sure you answer all of the problem solving questions, all of the exam style questions, and do the rest of them for practice as well. The quicker that you are at doing these, the more easier you're going to find it to spot the patterns in solving these types of trigonometric equations. The quicker you'll be able to get stuck into these types of problems, and the more comfortable you'll feel. If things go wrong, you'll try different methods, and you'll have lots of strings to your bow in terms of methods to solve these trigonometric equations by. But anyway, thanks very much for watching. Have a go at lots of the questions from exercise 7D, please, and ask your teacher for help if you need any. Thanks for watching.